All right, good morning, everyone. This is going to be kind of a collective review about some things we've been covering. Today is Thursday the 19th, just before Thanksgiving break. There is a quiz that is open today, and that quiz is called the Atomic Structure and Periodic Table Quiz, and it basically covers everything we've been learning about up through this point. Okay, so really quickly, I'm going to share a review activity and kind of go through that and discuss. So let me pause my video for just a moment and I will pull up that review. Okay. Okay, so at this point, you should be seeing the review activity, and a lot of you guys have this in your journal entry. So this is kind of review for those of you who are either virtual students or maybe in class and missed a few things. So remember that the atomic number is equal to the number of protons in an atom, and that determines how the periodic table is organized. Neutral atoms have no charge, and in a neutral atom, the number of protons is equal to the number of electrons. You will always assume that an atom is neutral unless you see a plus or a minus, or I've indicated that. So remember, when we're talking about atomic structure, there are three basic subatomic particles: protons, neutrons, and electrons. Each of them have a charge and are found in a specific area. Protons are positive, neutrons are neutral, and electrons are negative. Protons and neutrons both make up the atomic nucleus, and then surrounding them in those orbitals we've talked about are the negatively charged electrons. So remember that protons and neutrons are important in the nucleus, and specifically together, they maintain stability. If you think back to the virtual lab that we've looked at 3 or 4 different times, if the number of protons and neutrons aren't equivalent or similar, then the atom starts to shake around and wiggle and becomes unstable. So neutrons help maintain stability of the atomic nucleus. Okay, electrons are orbiting the atomic nucleus and they are attracted to the positive charge of the proton in the center. So that's basically what holds them in place. Other information we've been discussing is the atomic mass. The atomic mass is equal to the number of protons plus the number of neutrons. So remember, all of this information is in fact found on your periodic table. Okay, and I'm actually in just a moment going to pull up a periodic table and just kind of show you guys that so we can review that real quickly. Okay, so I'm going to swap my sharing here, and I'm going to share this periodic table for just a moment. So here's that periodic table. This is ptable.com. I can't recommend this website enough. You guys are going to be using it repeatedly, even into next week and beyond that. So it shows you all that information. So let's look at hydrogen here. So remember that hydrogen has an atomic number of 1. So when you were looking at the periodic table, the atomic number is always here at the top. So atomic number, H is the atomic symbol, hydrogen is the name, and below that is the atomic mass. This is equal to the number of protons plus the number of neutrons, okay? So this is something you need to know, what this information is and where to find it. All right, a few more things to review on the periodic table. Remember that there are 2 sections. There are groups and periods. So groups go across the top, 1 through 18. Periods go here. So the numbers 1 through 7 represent the periods, but to read those, you go across. Period 1, for example, includes hydrogen and helium. Period 2 includes lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Period 3 includes sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Okay, so you kind of see that pattern. And then, of course, your lanthanides and actinides down here. Lanthanides kind of fit in right here for period 6, and actinides fit in right here for period 7. These periods represent the number of shells or energy levels. So if you draw the Bohr models for hydrogen and helium, have 1 shell. If you draw the Bohr models for lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, they all have 2 shells and so on. So these have 3 shells, 4 shells, okay? That's what periods represent. Groups along the top correspond to the number of valence electrons. So this is group 1, group 2, okay? Remember, the number of valence electrons only holds true for groups 1, 2, and then 13 through 18. Groups 3 through 12 represent the transition elements or transition metals, and they don't always follow that pattern. Okay, so group 13, which includes boron, aluminum, gallium, indium, thallium, these all have 3 valence electrons. Group 14, carbon, silicon, germanium, tin, lead, etc., all have 4 valence electrons, 5 valence electrons, 6, 7, and then 8 valence electrons. Okay, so remember, periodic table is grouped into 3 major groups: metals, metalloids, and non-metals. And I'll briefly talk about characteristics of each of these in a few minutes. But metals, metalloids, and non-metals make up the bulk of them. Notice that the majority of the periodic table are metals, and within metals you have families. So families are alkali, alkaline earth, lanthanoids, actinoids, transition and post-transitional metals. We'll talk more about each of these after Thanksgiving. Metalloids are over here. They're kind of the intermediate in between. And lastly, your non-metals are your noble gases and the remaining portion of what we call reactive non-metals, okay? And so these guys are more reactive than compared to the noble gases. Remember, noble gases have a full outer shell, 8 electrons, so they fulfill the octet rule and don't typically interact. All right, so that's kind of the bulk of the review for the periodic table specifically. So I'm going to go back to sharing the review activity in my document here. All right, so we've kind of talked about all this, talked about atomic mass. We've also reviewed what groups and periods mean, but if you want to write this down in your notes, you have it here in front of you. Another activity that we did was practice drawing Bohr models. So in the virtual setting, you guys won't necessarily be sketching Bohr models. However, you should be able to identify them. Okay, so remember, the goal of the Bohr model was to show you the energy levels or the shells, and then of course the number of electrons found there. The energy levels start at the center and move outward. So if we were to zoom in on the example of a Bohr model here, you can see this is aluminum. Okay, remember, the first shell holds 2 electrons, second holds 8, and the third has a maximum of 18. Now, shells 4, 5, 6, and 7, some of them can hold up to 32, but for 8th grade science, we're just going to kind of end with discussing the third shell. So elements in period 3, basically. Okay, so this example is aluminum. It has an atomic number of 13. And remember, in a neutral atom, the atomic number represents the number of electrons as well as protons. So you can see here we have first shell, second shell, and third shell. 1, 2 electrons in the first. Then if you counted 1, 2, 3, 4, 5, 6, 7, 8 in the second, so that accounts for 10, then the last 3 will be in the third shell, 1, 2, and 3. So this is an example of a properly sketched Bohr model for aluminum. If we move down, there's a couple other things. One of these was determining the number of neutrons in an atom. So for example, let's use cesium. Cesium's atomic symbol is Cs. The atomic number is 55, which means it has 55 protons and essentially 55 electrons. The atomic mass is 132.905. If you say to yourself, where do I find all of this information, Ms. Littlepage? Well, it's on your handy dandy periodic table. So in-class students will have a physical copy, and I assume that virtual students will be able to access that P table immediately, the periodic table website. So here's your question. How many neutrons does cesium have? Well, let's determine that. You take the atomic mass minus the number of protons, and that tells you the number of neutrons. So let's type it out. The atomic mass is 132.905. The atomic number is 55, so that means it has 55 protons. Do our math. We end up with 77.905, which we then round to 78. So this is how you would determine the number of neutrons in an atom. The last couple of examples here are characteristics of metals, nonmetals, and metalloids, and I'm going to quickly go over that with you. And then lastly, you need to be able to locate the families of the periodic table. Noble gases, halogen, transition elements, etc. You need to be familiar with these, okay? Again, use ptable.com as a reference guide, okay? So I'm going to stop sharing this now, and I'm going to come back to my camera for just a moment. So this is a review of everything that will be included on the quiz. So again, today is the 19th. Periodic table and atomic structure quiz is open in Schoology. You have one opportunity to take this. So please make sure you do a good job and take your time. You will you will need a periodic table for reference. So while you're taking the quiz, I would expect you to be able to reference your ptable.com. All right. So really quickly, I'm going to go through a very brief, short PowerPoint on characteristics of metals and nonmetals, just so you guys have that, or those of you that have missed class or need to review or something like that, have access to it. This is also posted in Schoology. So you should be able to find it. So let me actually pull that up now. I'm gonna, for example, in fourth period, which is my virtual class, I'm gonna share my screen with you really quickly. So here's my fourth period virtual class. If you go into this week, I believe that is going to be in the, not Tuesday, must be in the Monday folder. All right, so in the Monday folder, and this should be either in Monday or Tuesday folder. Okay, so if you are a student and you missed a day during the week of Monday, during the week 3, somewhere in there, there's a PowerPoint labeled as classification of elements. If you would like to open that and download it and review, you can do so. Okay. So this is going to talk about metals versus nonmetals. So in the classification of elements, again, these are your major groups: metals, nonmetals, and metalloids. So what are some characteristics? Okay. Well, first of all, when we look at the periodic table, the bulk of elements are going to be metals. All right. So let me actually download this so we can look at it a little bit more closely. All right. There we go. That's a little better. So let me change my sharing for you guys really quickly because it's wanting to share on my alternative screen. Okay, so here we are. So metals versus nonmetals, we're just going to kind of briefly talk about the characteristics. So as you can see here in blue, all of those are metals. So the majority of elements that exist on the planet are in fact metals. The green represent metalloids and red represents your nonmetals. Okay, so what are some characteristics of metals? Well, first of all, they're located to the left of the zigzag line. So if I go back, what does that look like? Well, this is the zigzag line they're referring to. So they're over here. So periodic table, metals start at the left and go towards the right. So they're to the left of the zigzag line. Metals are shiny, meaning they have metallic luster. They're good conductors of heat and electricity. Okay, most of you know you don't go outside with a metal rod during a thunderstorm and hold it in the air because it's probably not going to end up in a positive way, right? You know that metal conducts electricity. It also conducts heat. If you're cooking in a metal pot and you touch the outer portion of the pot, it will feel hot because it heats up. So metals transfer heat and electricity. Most of the elements that exist on the planet are in fact metals. All metals except for mercury are solid at room temperature. So again, if you refer back to this periodic table, you'll see that all of these are in black, right? Except for mercury. So the fact that these are black letters mean that they are in fact solid at room temperature. Mercury is in blue because it is an exception to the rule. Okay, so mercury is liquid at room temperature. Most of you have heard of mercury. It is toxic at high levels. It is considered a heavy metal. Okay. Metals are also malleable and what we call ductile. They're malleable because we can bend them, we can flex them, you can heat them up and mold them into different shapes. They're ductile because they can be processed and pulled or drawn into wires without breaking or crumbling, right? So if you've ever looked inside a frayed cord or a frayed phone charger or something like that, you will see those very thin wires that are inside. Well, those are metals because they conduct electricity, meaning electrons travel through the cords to charge your phone or your laptop or whatever. Okay, and we can do that with metals because of the property of them being ductile, or what we call ductility. Okay, so again, metals, malleable, ductile, shiny, bendable, moldable, good conductors of heat and electricity. Those are your basic characteristics, and solid at room temperature except for mercury. Non-metals are usually dull in appearance. They are found to the right side of the periodic table, except for hydrogen, who is an exception to the rule. Hydrogen is, in fact, a non-metal. They're also very brittle. So when you think about non-metals, if you guys can visualize charcoal, that's a good visual. Think about charcoal. It's very crumbly, right? If you step on it or stomp on it or smash it, it crumbles and falls apart. Non-metals do not conduct heat or electricity very well. So you're not going to use them in a circuit board. You're not going to use them in a charger. You're not going to use them to transfer heat or electricity. Most of the non-metals are gases at room temperature. Bromine is unique because it is a liquid. So if you go back to the periodic table and you look at everything on there, hydrogen is a non-metal, it's a gas. Helium, neon, argon, krypton, all gases. Oxygen, nitrogen are gases as well. Things like carbon, sulfur, phosphorus, those are some examples of non-metals that are solids. But bromine is an exception because it is, in fact, at a liquid state at room temperature, which is around 23 degrees Celsius or 72 to 73 degrees Fahrenheit. What about metalloids? Well, metalloids make up that zigzag line in between, okay? And they're actually listed here. There's not very many. There's not a lot of metalloids. So they are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. So you can see them all right here. They make up the smallest portion of the elements on the periodic table. And they're basically intermediate. That's why they are located where they are, because they're kind of like a non-metal, kind of like metal. Okay, so they have characteristics of both. So we call them semiconductors. Okay, so they're not as good at conducting electricity as, let's say, metals, but they have some of those properties. All metalloids are solid at room temperature. One metalloid that is very important to humans is silicon. And so basically silicon is used in almost every single electronic that we have now. So they take silicon, which is again a metalloid, and they mix it with some other materials to kind of modify or increase its electrical properties. And then it can be molded and built into circuit boards that are in your phone and your computer, your PlayStation, your Xbox, whatever the case may be. Okay, so again, these are some very simple characteristics of metalloids. All right, so at the end of this, there are some practice questions. We're not going to go through this now, but I do encourage you guys to go through for a review and you can look up the answers. So there's about 6 practice questions here at the end. All right, so I'm going to pause now and stop screen sharing. All right, and I'm going to come back to you guys. So for today, this kind of takes us into most of what we've been doing. Okay, so at this point, we have reviewed for the quiz, which is today, 11:19. So you need to make sure you finish that. We've also reviewed periodic table. We talked about metals, non-metals, and metalloids. A couple other things to go through. Make sure that you're working on your atomic math challenge and that you are working on your web quest, periodic table web quest. So if you're not sure about those assignments or you have questions, please send me a message through Schoology and I will try to address them. All right. So enjoy your day and I will see you guys next time. Remember, please send me any questions you may have. Have a good day.